Alright, so this is problem 4 on the worksheet from last Friday, and it's problem 4 on the back here. And what you're given in this problem is that you have an 80-gram arrow moving at 80 meters per second, which hits a 10 kilogram block. And we have to find its the velocity of the system and the change its position. And the system, of course, I defined it as the arrow in the block. And the arrow does embed itself in the block and they move, forming a perfect inelastic collision. Now, the two equations I'd use for this is firstly P equals mv, and also the fact that it's always conserved, and also the fact that the final, and this is from kinematics, got that, and this is for the second part of the problem. Now, for the first part, what we have is the initial momentum, what we have to find first before the collision. And before the collision, our 80-gram arrow is moving 80 meters per second, so we have 80 grams converted to kilos here, 80 meters per second, and this comes out to 6.4 kilograms meters per second, which also does equal our final momentum. And the final momentum equals, to add to the long chain of equal signs here, mass of arrow and that final velocity of the system plus mass of block times final velocity of system. Or factoring out the final velocity, we can just sum up the masses to get 10.08 kilograms times final velocity. And now solving for final velocity is this equation that we're finally given. We get that final velocity is 0.6349 meters per second. So we have that value. Now, as the block is sliding along, if we treat this value here as our initial velocity, and because we know that the change in position will end when the block is at rest and this becomes 0, and we're also given this force opposing the motion, so that we do have an acceleration slowing the block down and it doesn't keep moving. We're given that this divided by the mass of system gives us our acceleration. And this comes out to 7.2 divided by 0.08, which comes to, I haven't memorized the value just yet, 5/7 or 0.7143. Now, plugging that in, we see firstly we have to multiply it by 2 and all. So, plugging in all these numbers in, I'll just draw an arrow so that you can follow the work a little better. It's becoming a bit messy. We get 0 equals 0.6349 squared, which gives 0.431 plus 2 times 5/7, which is 10/7, or 1.429 approximately times change in position. Now solving for, and of course this is negative because the way I define it is that the force applied is in the negative direction. So to draw a quick force diagram, if this is the direction of the velocity, we have our friction, which I called F sub k for some reason, in the negative direction. This is positive, and if you really want to say, this is the momentum as well. So that's negative. So we get 0.4031 divided by 1.429 This is our change in position. Change in position, which is 0.282. So our block almost moves a foot, 0.282 meters.